Hello everyone, my name is Yikan Pan. Today I will be presenting the results of my final project from the Machine Learning Foundation for Product Managers course. In this project, I adopted the CRISP-DM method, which includes the steps of business understanding, data preparation, modeling evaluation, and deployment. The goal of this project is to build a machine learning model to predict the electrical energy output of a combined cycle power plant. The steps I will apply in building the model includes feature selection, algorithm selection, hyperparameters adjustments, model training, and model evaluation. Our datasets includes 9,568 hourly average ambient environmental readings from sensors at the power plant. We will use temperature, ambient pressure, relative humidity, and exhaust vacuum as feature variables, while the net hourly electrical energy output will serve as the target variable. Through statistical analysis and data visualization, we can observe that the temperature and exhaust vacuum have a strong negative correlation with power output, and there is a strong positive correlation between temperature and exhaust vacuum as well. Apart from this, both humidity and ambient pressure have a moderate correlation with temperature. We will split the datasets into two parts, with 75% used for model training and for evaluating and comparing different types of models. The remaining 25% will be used for evaluating the performance of the final model. To maximize the use of our existing data and to avoid potential bias and data leakage in model performance, we adopted the K-fold cross-validation model evaluation method. So we divided training and validation datasets into 10 folds. Considering the linear nature of our observed input variables and target variable, we will try different types of regression models in this project. Based on the strong correlation observed between AT and V with our target variable PE in the previous data analysis, I tested the performance of OLS regression model, which is the linear regression model, under different feature variables in the first iteration. The first scenario included all feature variables, while the second scenario only used temperature and exhaust vacuum as feature variables. The evaluation metrics used in this project are R-squared, MAE, MSE, and RMSE. The performance of OLS regression model in the testing sets indicates that it performs better when using all data as feature compared to using only AT and V as feature variables. This suggests that a strong correlation between AT, V with target variable PE does not necessarily leads to causation. This might be because there is a moderate correlation between other variables with AT and V. Furthermore, by assessing the performance of OLS model on the testing sets, we find that the OLS regression model is stable and does not exhibit overfitting. After determining the feature selection, we will select the final model by comparing the performance of different types of regression models. In the second iteration, we will test the performance of linear regression model, lasso regression model, ridge regression model, and random forest regression model. During the training process, we also fine-tune some of the model's hyperparameters. We use the same evaluation metrics as before by comparing the performance of different models in the training sets. The random forest model performance is notably superior when contrasted with the other three regression models. We also find that applying regularization to the linear regression model did not significantly improve the model's performance. This might be because there is no significant difference in the correlation and influence of different feature variables on the target variable. After deciding to use the random forest model as the final model, we further evaluated model performance in the testing sets. The random forest regression model performance in the training sets and testing sets did not fluctuate significantly and even showed a slight increase, indicating that it does not overfit and is stable and suitable for predicting data.